The day is letting go of its warmth, and you can feel it happening all around you. This moment, this gentle transition from day to night, is one of the most beautiful performances in all of nature's theater. Your world is breathing, and tonight you're going to feel that breath as intimately as your own. Right now, as evening settles around you, the earth beneath your feet is releasing the heat it has collected throughout the day. Think of it like a warm stone you might hold in your hands after it's been sitting in sunshine. The stone gives back its warmth slowly, generously, the way the ground beneath you is giving back the sun's energy right now. This is called radiative cooling, but imagine it instead as the Earth's way of sighing, a long, satisfied exhale after a day spent gathering light. The air above you is moving in response to this gentle release of heat. Warm air, lighter than its cooler companions, begins to rise like invisible smoke from an extinguished candle. You can't see this movement, but your skin knows it's happening. Perhaps you felt it as that subtle shift in the evening breeze, the way the air seems to change its mind about which direction it wants to travel. As this warm air rises, it creates space below, a gentle vacuum that draws cooler air down from above, like water finding its level. This is convection, the atmosphere's way of stirring itself, of mixing its temperatures like cream swirling into coffee. The air around you is constantly rearranging itself, seeking balance, seeking comfort, much like you might adjust your blankets to find the perfect temperature for sleep. Tonight, imagine that you can feel this invisible dance happening in layers above your head. Close your eyes and picture the air as a series of transparent blankets, each one a different temperature, each one moving at its own pace. The blanket closest to the ground is releasing its warmth upward, while the blankets higher up are settling downward, cool and patient. This temperature dance creates something meteorologists call the boundary layer, that part of the atmosphere closest to the Earth's surface where your daily life unfolds. Think of it as the space where the sky and the earth have their most intimate conversations. It's here, in this boundary layer, that the weather you experience tomorrow is being quietly written tonight. The evening air holds memory. Every molecule of oxygen and nitrogen around you has been on countless journeys. Perhaps it was once part of a cloud above the Pacific Ocean, or maybe it carried the scent of pine from a forest 1,000 miles away. Now it's here with you, settling into the cool of evening, becoming part of this moment's particular breath. As the sun disappears completely, the cooling accelerates. Without the sun's energy constantly replenishing the Earth's warmth, the ground becomes like a bank account that's no longer receiving deposits. It can only give back what it has stored. The soil, the concrete, the leaves on trees, all of them begin their nightly ritual of returning heat to the air above them. This process creates what scientists call the nocturnal inversion, a gentle flipping of the atmosphere's usual temperature pattern. During the day, air typically gets cooler as you move higher up, like climbing a mountain where the peak is colder than the valley. But at night, especially on clear, calm evenings like this one, the coolest air settles near the ground, while warmer air hovers above it, creating a thermal blanket that holds the night's quiet mysteries. You are part of this process too. Your body, warm and alive, is adding its own gentle heat to the evening air around you. Every breath you take draws in the cooling atmosphere and warms it with your inner fire before releasing it back into the night. You are both observer and participant in this thermal dance, both audience and performer in the evening's quiet symphony. The plants around you are participating too in their own ancient way. As daylight fades, they stop their photosynthesis, that miraculous process of turning sunlight into life, and begin their own version of rest. The leaves that spent the day actively cooling themselves through transpiration, releasing water vapor like tiny air conditioners, now slow their activity, allowing the air around them to warm just slightly. Feel how the evening air moves differently than it did at noon. During the heat of the day, air movements were often sharp and quick, driven by the sun's intense energy, creating rapid heating and cooling. But now, as the sun's influence fades, the air moves more slowly, more deliberately, like a dancer changing from a quick tempo to a gentle waltz. This is the atmosphere's way of preparing for night, slowing down, settling in, finding its rhythm for the hours of darkness ahead. The thermal updrafts that might have carried hawks and eagles high into the afternoon sky are weakening now, replaced by gentler currents that barely disturb the leaves on trees. Listen carefully, and you might hear the subtle sounds of this thermal settling. The quiet creak of cooling metal, the soft whisper of air moving through grass, the distant murmur of temperature differences resolving themselves across the landscape. These are the sounds of the earth finding its equilibrium, the audio signature of a world transitioning from the active energy of day to the receptive quiet of night. The evening breath you're experiencing now is just the beginning of tonight's atmospheric story. As the hours pass, this gentle cooling will create conditions that allow other phenomena to emerge. The formation of dew, the development of fog in low places, the subtle shifts in air pressure that will influence tomorrow's weather. But for now, in this moment of transition, simply rest in the knowledge that you are surrounded by one of nature's most fundamental processes. The air around you is alive with thermal currents, engaged in an ancient dance of heating and cooling that has been happening every evening for billions of years, long before there were eyes to see it or minds to understand it. Above you, invisible rivers of air are beginning to form, carrying moisture from distant places toward tomorrow's weather. The air around you is full of water, though you cannot see it. Right now, as you rest in the gentle coolness of evening, millions of water molecules are floating invisibly through the space where you breathe. Each one a tiny traveler on an epic journey that began perhaps thousands of miles away. Think of the air as a vast, invisible ocean, and you are resting at its bottom, breathing in this sea of molecules that includes not just oxygen and nitrogen, but water in its most ethereal form. Water vapor, these molecules are so small, so perfectly dissolved in the air around you, that they move through the atmosphere like ghosts, carrying stories from places you may never visit. Some of the water molecules entering your lungs right now might have begun their journey this morning as part of the Pacific Ocean, lifted into the sky by the sun's gentle insistence. Others could have evaporated from a lake in the mountains, or risen from soil after yesterday's rain, or breathed out from the leaves of a forest hundreds of miles away. Each invisible droplet is writing its own chapter in the endless story of water's movement around our planet. This process, this constant lifting and carrying of water through the atmosphere, creates rivers in the sky that dwarf any waterway on Earth. Imagine the Mississippi River, but instead of flowing between banks of soil and stone, it flows through corridors of air, invisible and silent, carrying moisture from the Gulf of Mexico northward across the continent. These atmospheric rivers transport more water than all the earthbound rivers combined, yet they leave no wake, make no sound, cast no shadow. You are breathing in this aerial river right now. With each inhalation, you're taking in water that has been cycling through the atmosphere, the oceans, the soil, and the bodies of living things for millions of years. The water in your breath is ancient. Some of it might have fallen as rain on the first forests, or filled the first seas, or been exhaled by creatures that lived when the world was young. As evening deepens around you, the air's ability to hold this invisible water begins to change. Think of air as a sponge, with warm air being like a large, thirsty sponge that can soak up enormous amounts of water vapor. But as the air cools in the gentle evening temperatures, that sponge begins to shrink, gradually losing its capacity to hold all the moisture it carried during the warmer day. This is why evenings often feel more humid than afternoons, even when the actual amount of water in the air hasn't changed. The cooler air simply cannot hold as much moisture, so the same amount of water vapor becomes more concentrated, more present, more noticeable to your skin and lungs. You might feel this as a subtle thickness in the air, a gentle heaviness that wasn't there when the sun was high. Above you, in the layers of atmosphere that stretch toward space, this water vapor is beginning its transformation into something visible. As air rises and cools, carrying its cargo of invisible moisture higher and higher, it reaches a point where it can no longer hold all that water. This moment, this precise altitude where the air becomes saturated, is called the dew point. But think of it instead as the place where the invisible becomes visible, where water's ghost-like presence suddenly takes on form. At this magical height, water vapor begins to condense around tiny particles in the air. Specks of dust, grains of pollen, microscopic bits of salt that have traveled here from distant oceans. These particles, smaller than you could ever see, become the foundation for something magnificent, the birth of clouds. Picture this happening right now, perhaps a few thousand feet above where you rest. Water molecules having risen with the evening air encounter the cooler temperatures of higher altitudes and begin to cluster around these invisible particles. Each cluster grows molecule by molecule, like a pearl forming around a grain of sand, until it becomes large enough to catch and scatter light, a water droplet suspended in the sky. Millions of these droplets, each one born from the marriage of invisible vapor and microscopic dust, come together to form the clouds that drift across your evening sky. What appears solid and defined from your perspective on the ground is actually a community of countless individual droplets, each one floating freely in the air, each one a tiny miracle of physics and chemistry working in perfect harmony. These clouds are not static decorations painted across the sky. They are dynamic, living systems, constantly forming and dissolving, growing and shrinking, as the water within them responds to the changing conditions of temperature and pressure in the atmosphere around them. A cloud is like a thought made visible, temporary, beautiful, and always in the process of becoming something else.
The moisture that forms tonight's clouds carries with it the chemical signature of its origins. Water that evaporated from the ocean brings tiny amounts of salt. Water that rose from soil carries the essence of earth. Water that transpired from leaves holds traces of the life processes that released it. In this way, the clouds above you are libraries of the Earth's surface, storing information about distant places and carrying it across the sky. As you lie here in the evening air, you are participating in this grand cycle of water movement. Every breath you exhale adds a small amount of moisture to the atmosphere around you. Water that your body has warmed and humidified. Water that carries the warmth of your life into the cooling evening air. This moisture joins the vast atmospheric river, becoming part of the invisible flow that will eventually rise, condense, and perhaps fall as tomorrow's rain. The water vapor around you moves in currents you cannot see, following patterns created by temperature differences, pressure gradients, and the subtle influences of the landscape below. Mountains force these atmospheric rivers upward, causing them to release their moisture as rain or snow. Valleys channel them like invisible canyons. The warming and cooling of different surfaces, forests, lakes, cities, fields, create updrafts and downdrafts that guide the water's aerial journey. Tonight, as you rest, this invisible water cycle continues its ancient rhythm around you. Somewhere, water is evaporating from sun-warmed surfaces and beginning its rise into the atmosphere. Somewhere else, water vapor is condensing into droplets and beginning its fall back to Earth. The air you breathe is just one small part of this planetary circulation system, this endless exchange between the surface and the sky. Feel the humidity on your skin as more than just a physical sensation. Recognize it as your direct connection to the water cycle, your participation in the grand atmospheric circulation that connects you to every ocean, every cloud, every raindrop that has ever fallen. The moisture in the evening air around you is a messenger, carrying stories from faraway places and promising to carry your own warmth and breath onward into the night. Above you, invisible forces are already at work, creating differences in pressure that will guide tomorrow's weather, shaping the movement of these atmospheric rivers in ways both subtle and profound. You are sitting at the bottom of an ocean, not of water, but of air. Above you stretches a sea of atmosphere that reaches 50 miles into space, And every molecule of that vast aerial ocean is pressing down upon you with a force so constant, so perfectly balanced, that you barely notice it exists. Yet right now, as evening settles around you, this invisible ocean is speaking in a language older than words, telling the story of tomorrow's weather through the subtle poetry of pressure. Imagine the weight of all that air above you, every cubic inch from where you sit to the edge of space, layer upon layer of molecules stacked like invisible blankets. The pressure they create would crush you instantly if your body weren't perfectly designed to push back with equal force. You are a submarine built for air, engineered by millions of years of evolution to exist in perfect equilibrium with the atmospheric ocean surrounding you. This pressure, this gentle, constant embrace of the atmosphere, is not the same everywhere. Like the surface of a pond disturbed by wind, the pressure of the atmosphere rises and falls in slow, graceful waves that sweep across continents. These waves of pressure difference are what meteorologists measure with their barometers, but think of them instead as the breathing of the earth itself. Long, slow inhales and exhales that take days to complete. Right now, somewhere far from where you rest, the air pressure might be rising as millions of tons of atmosphere settle down like a heavy blanket over the landscape. This creates what scientists call a high-pressure system, but imagine it as a place where the aerial ocean grows deeper, where the weight of all that air above you presses down with just a little more force than usual. In these regions, the air tends to sink gently downward, spreading out as it approaches the ground like honey poured from a great height. Meanwhile, in another part of your world, the pressure might be falling as air rises and the atmospheric ocean grows shallower. These low-pressure systems are like valleys in the aerial sea, places where the weight of the atmosphere lessens just enough to allow air to rise more freely, creating space that draws in surrounding air like a gentle whirlpool made of wind. Your body knows about these pressure changes before your conscious mind does. Perhaps you felt it as a subtle ache in old injuries when storms approach, or a sense of heaviness that seems to settle in your bones. This isn't imagination. Your body is an exquisitely sensitive barometer, able to detect pressure changes of just a few millibars. Every cell in your body is in constant negotiation with the atmospheric pressure around it, expanding and contracting ever so slightly as the weight of the aerial ocean above you shifts. The fascinating thing about these pressure systems is how they move. Like weather itself, they travel across the landscape in patterns that follow the ancient rhythms of our spinning planet. The Earth's rotation, combined with the uneven heating of its surface, creates a complex dance of pressure waves that circle the globe in predictable paths. What begins as a subtle change in pressure over the Pacific Ocean can travel thousands of miles, eventually arriving at your location days later as the high or low pressure system that determines whether you wake to sunshine or rain. These traveling pressure systems carry with them the signatures of the places they've been. A high-pressure system that formed over the cold waters of the northern Pacific brings different qualities than one born over the warm deserts of the Southwest. Each system is like a messenger, carrying news from distant parts of the world, and your body reads these messages in the language of pressure, temperature, and humidity.
Tonight, as you rest in the evening air, pressure systems hundreds of miles away are already influencing the weather you'll experience tomorrow. The gentle settling of high pressure over the Great Plains might be pushing tonight's clouds toward you. The development of low pressure over the Gulf of Mexico could be drawing moisture northward that will become tomorrow afternoon's thunderstorms. The atmosphere is always writing the future in the present moment, using pressure as its pen. Think of pressure systems as the circulatory system of the planet's atmosphere. Just as your blood carries nutrients and information throughout your body, these moving areas of high and low pressure carry energy, moisture, and temperature differences around the globe. They are the Earth's way of sharing resources, bringing rain to dry places, carrying warmth toward cold regions, distributing the energy that drives all weather. The boundaries between these pressure systems are where the most interesting weather happens. When a mass of high-pressure air meets a region of low pressure, they don't simply blend together like mixing paint. Instead, they maintain their distinct identities, creating fronts, zones of transition where different types of air masses slide past or over each other, sometimes generating the dramatic weather of storms and the gentle progression of changing seasons. You can think of these fronts as the places where different chapters of the atmosphere's story meet. A warm, humid air mass carrying the signature of the Gulf of Mexico encounters a cool, dry air mass that began its journey over Canada. Where they meet, the warm air rises over the cooler air, creating clouds, precipitation, and all the dynamic weather that makes each day unique. Even on the calmest nights, like tonight, these pressure systems are in constant motion around you. The air pressure where you sit might be rising so slowly that no instrument could detect the change from minute to minute. Yet over the course of hours, that slow rise or fall will help determine whether tomorrow brings clear skies or gathering clouds. Your evening rest is taking place within this grand symphony of pressure changes. Every breath you take draws in air that carries the signature of these distant pressure systems. The oxygen molecules entering your lungs might have begun their journey in a high-pressure system over the Arctic, gaining the crisp, clean quality that comes from cold, dense air. Or they might have originated in a low-pressure system over the tropics, carrying with them the warmth and moisture of equatorial regions. The remarkable thing about atmospheric pressure is its invisibility combined with its profound influence. You cannot see it, smell it, or hear it directly. Yet it shapes every aspect of the weather you experience. It determines whether clouds form or dissipate, whether rain falls or evaporates before reaching the ground, whether the air feels heavy and still or light and breezy. As you settle deeper into tonight's quietude, remember that you are resting at the intersection of multiple pressure systems, each one contributing its influence to this moment's particular atmospheric conditions. The pressure of the air around you is the result of countless factors: the temperature of distant oceans, the heating of faraway deserts, the cooling of polar ice, the rotation of the planet beneath you. This invisible ocean of air that surrounds you is always in motion, always changing, always carrying messages between different parts of the world. And somewhere in that gentle, constant pressure against your skin, the atmosphere is already whispering hints about the clouds that will form above you while you sleep. Above you, in the high realm where eagles struggle to breathe and your exhaled breath would instantly crystallize into ice, something magnificent is happening. Water, the same water that flows from your tap and fills your bathtub, is performing one of nature's most beautiful transformations, gathering itself into the floating islands we call clouds. These aren't solid masses as they appear from your earthbound perspective, but rather communities of countless water droplets, each one so small that millions could dance on the head of a pin, yet together creating the majestic architecture of the sky. Imagine each cloud as a city suspended in air, populated not by people, but by billions of water droplets, each one a perfect sphere, no larger than the period at the end of this sentence. These microscopic citizens exist in a state that seems to defy logic, too heavy to float, yet somehow refusing to fall, held aloft by forces so delicate that a whisper of wind can reshape their entire community. The birth of each droplet is a story of attraction and accumulation. High in the atmosphere, where the air has cooled to the point where it can no longer hold all its invisible water vapor, molecules begin to seek something solid to cling to. They find salvation in particles tinier than dust, microscopic grains of salt that traveled here from ocean spray, pollen that drifted up from distant meadows, or specks of clay lifted by desert winds half a world away. These particles, called condensation nuclei, become the seeds around which water molecules gather like children clustering around a storyteller. One molecule attaches, then another, then hundreds more, each addition making the growing droplet slightly heavier, slightly more visible, until what began as an invisible speck becomes large enough to catch and scatter sunlight, contributing its small brightness to the cloud's collective glow. But clouds are not passive collections of fluting water. They are dynamic, living systems in constant motion, constantly changing, constantly being born and dying in cycles measured in minutes or hours. The cloud you observe drifting peacefully across the evening sky is not the same cloud it was an hour ago. Its droplets have evaporated and reformed countless times, some growing large enough to begin their journey toward Earth as rain, others shrinking back into invisible vapor to wait for another opportunity to become visible. Think of clouds as the atmosphere's way of thinking out loud. They are the visible expression of invisible processes. The condensation of water vapor made manifest, the sculpture of air currents rendered in white and gray, the art created when temperature, pressure, and humidity collaborate in the vast studio of the sky. Each cloud's shape tells the story of the air currents that formed it, the temperature gradients that shaped it, and the moisture content that gave it substance. Tonight, as evening light plays across the clouds above you, each droplet within them acts as a tiny lens, bending and scattering light in ways that create the subtle colors and shadows you see. The white of a cloud comes from sunlight bouncing off billions of these microscopic spheres, each one reflecting light in all directions like a minute disco ball. The gray of a storm cloud develops when the droplets become so numerous and tightly packed that they absorb more light than they reflect, creating shadows within the cloud itself. The temperature at cloud level, often 30 or 40 degrees colder than the air where you rest, creates a unique environment where water exists in multiple forms simultaneously. Some droplets remain liquid, even at temperatures well below freezing, in a state called supercooling, waiting for the right trigger to instantly transform into ice. Others freeze immediately upon formation, creating ice crystals so small and perfectly formed they make snowflakes seem gigantic by comparison. These ice crystals and supercooled droplets coexist in the same cloud, creating a microscopic drama of phase changes and energy exchanges. When a supercooled droplet finally freezes, it releases a tiny amount of heat, not enough for you to feel from the ground, but significant enough to warm the surrounding air and influence the cloud's development. This process, repeated billions of times throughout a single cloud, can provide enough energy to fuel the growth of towering thunderstorms or the gentle persistence of layered stratus clouds. The clouds above you are also repositories of energy, vast batteries storing and releasing the power that drives weather systems. Every droplet that forms releases a small amount of latent heat, energy that was absorbed when the water first evaporated from the Earth's surface, now released as vapor, condenses back into liquid. This energy, multiplied across billions of droplets in a single cloud, represents enormous amounts of power, equivalent to hundreds of atomic bombs, yet released so gently and gradually that it manifests as the soft warmth you might feel when a cloud passes overhead on a cool day. Different types of clouds tell different stories about the atmospheric conditions that created them. The high, wispy cirrus clouds that look like brushstrokes across the sky form in the cold, thin air of the upper atmosphere, where water vapor freezes directly into ice crystals without ever becoming liquid droplets. These ice crystal clouds often appear days before a weather system arrives, acting as the atmosphere's early warning system, writing messages about tomorrow's weather in script so delicate it seems almost calligraphic. The puffy cumulus clouds that look like cotton balls floating in blue sky form when warm air rises from the heated ground below, carrying moisture upward until it reaches its condensation level. These clouds are the signatures of thermal currents, marking the places where the Earth's surface has warmed the air enough to send it skyward. On calm days, they drift lazily across the sky. But given the right conditions, they can grow into towering giants that reach the edge of space. The flat, layered stratus clouds that sometimes cover the entire sky like a gray blanket form when a large mass of air is lifted gradually over a wide area, often by weather fronts or topographic features like mountain ranges. These clouds can persist for days, creating the kind of overcast conditions that make the world feel soft and muted, as if someone has drawn gauze across the sun. As you rest here in the evening air, the clouds above you are engaged in their own version of sleep and dreams. Some are dissolving as the air around them warms or dries, their droplets evaporating back into invisible vapor. Others are forming as cooling air reaches its saturation point, water molecules clustering around condensation nuclei to create new communities of floating water. Still others are changing shape as air currents stretch and compress them, like clay being worked by invisible hands. The clouds you see tonight carry within them the potential for tomorrow's weather. They hold rain that might fall while you sleep, snow that could blanket your world by morning, or simply the promise of continued overcast skies that will keep the day cool and gentle. Within their floating masses, droplets are colliding and combining, growing large enough to overcome the updrafts that hold them aloft, preparing for their eventual journey back to Earth. But clouds are more than just weather makers. They are the planet's climate regulators, reflecting sunlight back to space during the day and trapping heat at night like a blanket. They moderate temperatures, distribute moisture, and create the conditions that make life possible on Earth. The water cycle itself depends on their ability to transport moisture from oceans to continents, from low places to high, from wet regions to dry. Tonight, as you settle into sleep, imagine yourself rising up through the layers of atmosphere to visit these floating cities of water. Feel how the temperature drops as you ascend. Watch the droplets form and reform around you. Sense the gentle energy exchanges that power the cloud's existence. In the morning, when you wake and look up at whatever clouds grace your sky, you'll see them not as distant decorations, but as active participants in the grand conversation between Earth and atmosphere. And even as these clouds drift and change above you, invisible currents of air are already moving around them, carrying the subtle fragrances and whispered secrets that will shape the wind's stories through the night. The air around you is never truly still. Even on the calmest evening, when leaves hang motionless and not a single blade of grass seems to stir, the atmosphere is alive with movement so subtle it exists below the threshold of human perception. Molecules of air drift past your skin in currents measured not in miles per hour, but in whispers. Gentle flows that carry within them the breath of distant places and the promise of tomorrow's weather. Tonight, as you rest in the gathering darkness, imagine yourself becoming sensitive to these microscopic movements of air. Feel how each molecule of oxygen and nitrogen around you has its own trajectory, its own story of where it has been and where it is going. Some have drifted here from forests where they mingled with the exhalations of ancient trees. Others have traveled from oceans where they danced with salt spray and absorbed the warmth of tropical sunshine. Each one carries the chemical signature of its journey, making the air around you a library of Earth geography written in molecular script. Wind begins with the simplest principle. Air flows from places where there is more of it to places where there is less. But this elementary truth manifests in ways both grand and infinitely subtle. The heating of a sun-warmed parking lot creates a microscopic low-pressure zone that draws air inward from all directions. The cooling of a pond at evening creates a gentle settling of air that spreads outward like ripples on water. These tiny pressure differences, too small for any barometer to measure, create air movements that touch your skin with the delicacy of silk. The wind you feel or don't feel on any given evening is the sum of countless such pressure differences playing out across landscapes you may never see. A mountain range 1,000 miles away heats its eastern slopes in the morning sun, creating updrafts that influence pressure patterns that eventually contribute to the gentle breeze that might stir the curtains at your window tonight. A cool lake in a distant valley creates its own pattern of air circulation that adds its voice to the atmospheric chorus that determines whether tonight's air will be still or stirring. This is the beautiful complexity of wind. It connects everything to everything else. The air that moves past you now has been in motion for days, weeks, sometimes months, following paths determined by the rotation of the earth, the heating of oceans, the cooling of ice caps, and the countless interactions between land and sky that create the three-dimensional rivers of moving air we call wind patterns.
The Earth's rotation adds its own signature to every movement of air, turning what would otherwise be straight-line flows into the graceful curves and spirals that characterize wind patterns around the globe. This effect, called the Coriolis force, is so subtle you cannot feel it directly, yet it shapes every breeze. In the northern hemisphere, it gently deflects moving air to the right, creating the clockwise circulation around high-pressure systems and the counterclockwise swirl around areas of low pressure. It's as if the planet itself is conducting the orchestra of atmospheric motion, adding curves and grace notes to what would otherwise be a simple song. The landscape around you creates its own wind music. Valleys channel air like rivers flowing between banks of earth and stone. Mountains force air upward, creating updrafts on windward slopes and downdrafts on the leeward side. Forests slow the wind near the ground while allowing it to flow freely above the canopy, creating layers of air movement at different speeds and different heights. Lakes and rivers create their own thermal circulations as water and land heat and cool at different rates throughout the day and night. Tonight, as the Earth releases the day's accumulated heat into the cooling air, these landscape features are creating a complex symphony of air movements. Cool air is pooling in valleys like invisible water, flowing slowly downhill toward lower elevations. Warm air is rising from surfaces that still hold the sun's heat, rocks that baked all day, pavement that absorbed and stored thermal energy, south-facing slopes that caught the afternoon light. These vertical movements of air create opportunities for horizontal flows as the atmosphere seeks to balance these temperature differences. The wind carries more than just air from place to place. It is the atmosphere's messenger service, transporting pollen from flowers to create new life, carrying seeds to distant soil where they will grow into tomorrow's forests, distributing the spores of fungi and the eggs of insects across continents. The air moving past you tonight might carry dust from African deserts, salt crystals from Pacific storms, or volcanic ash from eruptions that occurred years ago and thousands of miles away. But wind also carries the intangible, the scents that tell stories of place and season. The molecules that create the smell of rain approaching are lifted by wind from the moist earth where rain has recently fallen, transported through miles of atmosphere to reach your nose with news of distant showers. The fragrance of blooming flowers travels on air currents that connect you to meadows and gardens far beyond your sight. Even the clean, empty smell of snow is carried by wind from regions where winter holds sway. The speed at which wind moves varies dramatically with height above the ground. Near the Earth's surface, friction slows the air's movement, creating the gentle breezes or dead calms you experience at ground level. But a few hundred feet above you, the same air mass might be racing along at speeds that would knock you off your feet. This vertical variation in wind speed creates layers of motion in the atmosphere, like sheets of moving air sliding past each other at different velocities. Aircraft pilots navigate these layers of wind, climbing or descending to find currents that will carry them more efficiently toward their destinations. Birds, particularly migrating species, are masters of reading these aerial highways, using their intuitive understanding of wind patterns to travel thousands of miles with minimal effort. They sense pressure changes and air movements that human instruments can barely detect, riding the invisible escalators and moving walkways of the sky. The wind's influence on weather is profound and subtle. It brings together air masses of different temperatures and humidities, creating the boundaries where weather happens. It transports moisture from oceans to continents, ensuring that rain falls far from the bodies of water where it originally evaporated. It helps distribute heat from equatorial regions toward the poles, moderating temperatures and making more of the planet habitable. On a local scale, wind affects weather in ways both obvious and hidden. It can disperse fog by mixing dry air with humid air near the ground. It can prevent frost by keeping air moving and preventing cold air from settling in low places. It can intensify storms by feeding them energy and moisture, or it can tear them apart by creating wind shear that disrupts their circulation patterns. As you rest here in the evening quiet, the wind, even if you cannot feel it, is performing countless small services for the living world around you. It is helping plants exchange gases with the atmosphere, enabling photosynthesis and respiration. It is cooling surfaces that would otherwise overheat and warming surfaces that might otherwise grow too cold. It is mixing layers of air that would otherwise stagnate, ensuring that oxygen and carbon dioxide remain well distributed throughout the lower atmosphere. The absence of wind can be as significant as its presence. On perfectly still nights, temperature inversions form more easily, trapping cool air near the ground and creating conditions where dew and frost are more likely to develop. The lack of air movement allows scents to linger and concentrate, making the night air rich with the accumulated fragrances of the day. Sounds travel differently in still air, sometimes carrying farther and more clearly than they would when wind creates background noise and turbulence. Think of the wind as the atmosphere's circulation system, performing for the planet the same essential function that blood circulation performs for your body. Just as your cardiovascular system transports nutrients, oxygen, and waste products throughout your body, wind patterns transport energy, moisture, and particles throughout the Earth's atmosphere. Without this constant mixing and movement, some regions would become too hot, while others would become too cold. Some areas would flood, while others would desiccate. The wind that may or may not touch your skin tonight is part of circulation patterns that extend around the globe and reach from the Earth's surface to the edge of space. trade winds that blow steadily across tropical oceans, jet streams that race around the planet at high altitude, polar easterlies that bring Arctic air southward. All of these are connected in a single, integrated system of atmospheric motion that makes weather possible and life sustainable. Even in stillness, the potential for movement remains. Air masses are like water behind a dam, always ready to flow when conditions create pressure differences. The perfectly calm evening you might be experiencing now contains within it all the elements necessary for tomorrow's breeze, temperature gradients waiting to develop, pressure systems waiting to move, the Earth's rotation continuing its eternal influence on every particle of air. And within this moving atmosphere, water continues its patient work of rising and falling, gathering and dispersing, preparing for the gentle mathematics of precipitation. In the darkness above you, mathematics is unfolding with the quiet precision of poetry. Each potential raindrop suspended in tonight's clouds is solving an equation of physics so elegant that it seems almost miraculous, calculating the exact moment when it will become heavy enough to overcome the updrafts that hold it aloft, determining the precise trajectory it will follow through miles of air, finding its way back to the earth through a geometry written in gravity and grace. Think of every raindrop as a tiny mathematician, constantly measuring its own weight against the forces that would keep it floating. Inside the clouds above you, water droplets begin their existence smaller than the period at the end of this sentence, each one a perfect sphere held in suspension by air currents too gentle for you to feel, but strong enough to support these microscopic worlds of liquid water. They drift through their aerial environment like thoughts seeking form, colliding and combining in a dance that follows laws both beautiful and precise. The mathematics of rain begins with collision. As millions of these microscopic droplets move through the cloud at slightly different speeds, carried by imperceptible air currents, they encounter one another with the randomness of stars in space and the inevitability of tide meeting shore. When two droplets touch, surface tension, that mysterious force that holds water together, pulls them into a single, larger drop. This new droplet, now slightly heavier than its parents, falls through the cloud at a marginally faster speed, increasing its chances of encountering and absorbing even more droplets. This process, called coalescence, creates a cascade of growth that transforms invisible cloud particles into visible precipitation. A droplet that began with a diameter smaller than a human hair can grow through countless collisions until it becomes large enough to fall as rain. The mathematics governing this growth follows patterns that would fascinate any physicist. Power laws and probability distributions that describe how size increases with time, how collision rates change with droplet dimensions, how gravity gradually overcomes the forces of suspension. But the story of rain involves more than just collision and growth. Temperature plays its own mathematical role in determining whether water falls as rain, snow, or something in between. High in the atmosphere, where the air is thin and cold, many of the droplets in clouds exist as ice crystals, tiny, perfectly symmetrical structures that grow through a different mathematical process called deposition, where water vapor transforms directly into ice without ever becoming liquid.
These ice crystals follow their own geometric rules, building themselves according to the hexagonal symmetry that gives snowflakes their six-sided beauty.
Even if they melt completely before reaching the ground, their influence on the cloud's mathematics is profound. Ice crystals grow more readily than water droplets in the mixed-phase regions of clouds, where ice and supercooled water coexist, creating a process called the Bergeron-Findyson mechanism, a delicate balance of sublimation and condensation that can trigger precipitation even when droplet collision alone would not be sufficient. The journey from cloud to ground involves its own mathematical precision. As a raindrop falls, it encounters air resistance that shapes both its form and its velocity. Small drops remain nearly spherical, their surface tension strong enough to maintain a perfect curved shape. But larger drops, those that have grown fat through many collisions, begin to flatten as air pressure pushes against their leading surface. The largest drops, those approaching the size of small peas, become so distorted by air resistance that they eventually break apart, spawning smaller drops that begin their own mathematical journey toward the earth. Terminal velocity, the maximum speed a falling object can achieve when air resistance exactly balances gravitational force, varies with droplet size in ways that seem almost choreographed. Tiny drizzle drops, barely large enough to see, fall at speeds of only a few feet per second, drifting downward like gentle thoughts. Medium-size raindrops descend at speeds of 10 to 15 miles per hour, fast enough to create the familiar drumming sound on roofs and windows. The largest drops, just before they break apart, can reach speeds of 20 miles per hour or more, carrying enough energy to splash when they strike surfaces. This variation in fall speeds creates a natural sorting mechanism in the atmosphere. Smaller drops, falling more slowly, have more time to evaporate during their descent, particularly on dry days when the air below the cloud contains little moisture. Only the larger, faster-falling drops complete the journey to the ground, which is why light rain consists primarily of smaller droplets, while heavy downpours are dominated by larger ones. The atmosphere performs its own quality control, filtering precipitation through the mathematics of evaporation and fall time. The shape of raindrops themselves defies common expectation. Despite countless drawings that show them as teardrops, falling raindrops are actually nearly spherical when small, becoming flattened spheres when medium-sized, and developing into shapes resembling hamburger buns when large. Surface tension, that molecular force that holds water together, works constantly to pull each drop into the most efficient shape, a sphere, while air resistance works to distort that shape. The final form of each drop represents a dynamic equilibrium between these competing forces, a three-dimensional solution to the physics of falling water. The mathematics of where rain falls involve scales both vast and intimate. Global weather patterns, driven by the planet's rotation and the uneven heating of its surface, create circulation systems that transport moisture from oceans to continents. These planetary scale equations determine which regions receive abundant precipitation and which remain dry, shaping climates and ecosystems across the Earth. But at the local level, the mathematics become more personal and immediate. The hill behind your house creates its own precipitation mathematics through orographic lifting, the process by which air masses are forced upward by topography, cooling as they rise and releasing their moisture as rain or snow on the windward slopes. The temperature difference between a nearby lake and the surrounding land creates convective patterns that influence where afternoon thunderstorms develop. Even the urban heat island effect of a distant city can alter precipitation patterns dozens of miles away, as the mathematics of heating and cooling play out across landscapes both natural and human-made. Rain carries within its mathematics the memory of its origins. Each drop that might fall tonight contains water molecules that have been cycling through the atmosphere, oceans, and living systems of Earth for billions of years. The isotopic signature of these molecules, the precise ratios of different forms of hydrogen and oxygen, tells the story of where the water evaporated, how long it spent in the atmosphere, and what temperatures it encountered during its aerial journey. Scientists read these chemical equations like hieroglyphs, decoding the history written in molecular mathematics. The timing of precipitation follows patterns both predictable and chaotic. Weather systems move across landscapes with speeds and trajectories that can be calculated days in advance, following the mathematical laws of fluid dynamics and thermodynamics. Yet the exact moment when rain begins to fall, the precise location where the first drops strike the ground, emerges from mathematical systems so complex and sensitive that small changes in initial conditions can lead to dramatically different outcomes. The mathematical principle underlying what meteorologists call the butterfly effect.
As you rest here in the evening quiet, the mathematics of precipitation are unfolding above you, whether or not rain actually falls tonight. Cloud droplets are colliding and coalescing according to the laws of probability and physics. Ice crystals are growing through the precise geometry of hexagonal lattices. Air currents are lifting moisture and cooling it through the predictable mathematics of adiabatic processes. Temperature gradients are determining phase changes through the elegant equations of thermodynamics. Even if no rain reaches the ground where you lie, the mathematical processes that create precipitation are operating with quiet precision throughout the atmosphere around you. Water vapor is condensing into droplets too small to fall, then evaporating back into invisible gas in cycles measured in seconds or minutes. The atmosphere is performing countless calculations, testing and retesting the conditions necessary for precipitation, preparing for the moment when all variables align to send water earthward. The mathematics of rain extend beyond the physical processes of drop formation and descent. Precipitation creates its own patterns when it reaches the ground. Infiltration rates that depend on soil composition and moisture content. Runoff patterns that follow the mathematical curves of watersheds and drainage basins. Evaporation rates that vary with temperature, humidity, and surface area. Each raindrop that falls becomes part of larger mathematical systems that govern how water moves through landscapes and ecosystems. Tonight, whether rain visits your window or remains a mathematical possibility suspended in distant clouds, you are surrounded by the quiet equations that govern one of Earth's most essential processes. The water cycle itself is a vast mathematical system, conserving mass while redistributing energy, following the laws of physics while creating the conditions that make life possible. In the patient mathematics of precipitation, invisible vapor becomes visible rain, completing calculations that began when water first evaporated from ancient seas. And as these mathematical processes continue their work above you, the very air around you is participating in its own quiet equations, slowly changing temperature as the night deepens and the earth releases its stored warmth into the cooling darkness. The darkness that surrounds you now is more than the absence of light. It is the presence of cooling, a slow and gentle transformation that touches every molecule of air around you. As the sun's energy fades from memory and night claims the sky, temperature becomes the quiet conductor of an atmospheric orchestra, directing the movements of air, the formation of dew, and the subtle dance of thermal currents that will shape your sleeping world until dawn returns. Feel the air against your skin and know that you are sensing the most fundamental force in weather, the movement of heat energy through the atmosphere. Every breath you take draws in air that carries the thermal signature of its journey. Molecules that have been warmed by contact with sun-heated surfaces and cooled by their rise into the upper atmosphere. The temperature you feel is not just a number on a thermometer, but the sum of countless energy exchanges, each one following the ancient laws of thermodynamics with mathematical precision. Tonight, as you rest in the gathering coolness, the earth beneath you is performing its nightly ritual of thermal release. All day, the ground absorbed energy from the sun, storing it in soil and stone, in pavement and rooftops, in the molecular structure of everything the sunlight touched. Now, with the sun's energy no longer replenishing this thermal bank account, the Earth begins its generous return of heat to the atmosphere above, warming the air through direct contact in a process called conduction. But this warming happens in layers, creating a vertical architecture of temperature that changes with height above the ground. The air closest to the Earth's surface receives the most direct heating from the cooling ground, making it warmer than the air just a few feet higher. This creates what meteorologists call a temperature inversion, a gentle flipping of the atmosphere's usual thermal structure, where warm air lies beneath cool air instead of above it. Imagine the atmosphere around you as a cake with invisible layers, each one a different temperature. Near the ground where you rest, the air might be pleasantly warm from the Earth's radiating heat. A few feet above your head, the air has already begun to cool, no longer receiving the direct thermal influence of the ground. Higher still, at the level of treetops and rooftops, the air grows cooler yet, creating a thermal staircase that ascends into the night sky. This layered cooling creates its own weather patterns on the smallest possible scale. Warm air near the ground, being less dense than the cooler air above it, wants to rise, but the temperature inversion creates a lid that prevents this upward movement. Instead of the vigorous mixing that occurs during the day, the night air settles into stable layers, each one finding its own thermal equilibrium. This creates conditions perfect for the formation of dew, frost, and the gentle fogs that sometimes fill valleys in the early morning hours.
The rate at which temperature changes with height during these clear nights follows patterns so regular that scientists have given them mathematical equations. The cooling rate, typically about 3.5 degrees Fahrenheit for every 1,000 feet of elevation, reflects the fundamental physics of how air releases heat through radiation to the star-filled sky above. This radiation cooling is the same process that makes your body feel chilled when you step outside on a clear winter night, even when the air temperature is relatively mild. Different surfaces around you cool at different rates, creating a thermal patchwork across the landscape. Water bodies, with their enormous capacity to store heat, cool slowly and steadily, releasing their warmth gradually through the night. Bare soil and pavement, which absorbed heat readily during the day, now give it up just as eagerly, cooling rapidly once the sun's energy is gone. Grass and vegetation cool quickly at their surfaces, but may remain warmer at root level, where the insulating properties of organic matter slow the release of stored heat. These temperature differences, measured in just a few degrees, create microscopic weather systems around you. Air cooled by contact with rapidly cooling surfaces becomes denser and begins to settle into low places, like an invisible, slow-moving liquid. This cool air pools in valleys, basements, and depressions in the landscape, creating frost pockets where temperatures can drop significantly below those in surrounding areas. Meanwhile, hilltops and elevated areas, no longer receiving the settling cool air, remain relatively warm through the night. The human body becomes its own microclimate in this cooling world. Your core temperature remains constant, but your skin adjusts to the changing thermal environment around you. The warmth radiating from your body creates a thin layer of heated air that rises gently upward, carrying with it moisture from your breathing and perspiration. This personal thermal plume connects you to the larger patterns of heat movement happening throughout the atmosphere, making you a participant in the night's thermal symphony rather than merely an observer. As the hours pass, the cooling continues in waves that penetrate deeper into the earth and higher into the atmosphere. The first few inches of soil, warmed throughout the day, release their heat into the night air within the first few hours after sunset. But deeper layers of earth, insulated by the soil above them, continue to hold and slowly release their stored warmth throughout the night, creating a steady but diminishing source of heat that helps moderate the cooling process. The atmosphere itself participates in this cooling through its interaction with the vast coldness of space. On clear nights like this one, the thin air above you radiates heat upward toward the stars, cooling through direct energy loss to the universe beyond. This radiative cooling is most effective when the sky is clear, allowing heat to escape freely, and least effective when clouds act like a blanket, trapping and re-radiating warmth back toward the Earth's surface. Water vapor in the air adds its own complexity to the night's thermal story. As air cools and its capacity to hold moisture decreases, some of that invisible water vapor begins to condense, releasing latent heat in the process. This heat release, the same energy that was absorbed when the water first evaporated, provides a subtle warming effect that can slow the cooling process and influence when and where dew forms on surfaces throughout your nighttime world. The temperature patterns developing around you right now are writing tomorrow's weather forecast in thermal ink. The rate of cooling will determine whether morning brings clear skies or fog-filled valleys. The development of temperature inversions will influence how pollutants disperse and how sounds carry through the still air. The formation of frost will depend on whether temperatures drop below the freezing point at ground level, even if the air just a few feet higher remains above 32 degrees. Different materials around you respond to this cooling with their own thermal personalities. Metals, excellent conductors of heat, quickly match the temperature of the cooling air around them. Wood, a better insulator, holds its warmth longer, but eventually surrenders it to the night. Glass surfaces cool rapidly and often become the first places where dew forms as water vapor condenses on these smooth, cool surfaces. Stone and concrete, which stored significant heat during the day, release it slowly and steadily, creating warm spots in the cooling landscape. The temperature of twilight create opportunities for thermal circulation patterns that exist only in the quiet hours of night. Cool air flowing downhill like an invisible river. Warm air rising from still heated surfaces. The gentle mixing that occurs where different air masses meet. All of these processes happen below the threshold of human perception, yet profoundly influence the atmospheric conditions that surround your rest.
Even the smallest temperature differences become significant in the still air of night. A difference of just 2 or 3 degrees between nearby locations can determine whether dew forms, whether fog develops, whether the air remains clear or becomes misty with condensed water vapor. These subtle thermal variations, invisible during the turbulent mixing of daytime, emerge during the calm conditions of night, like a thermal landscape revealed only in darkness. The cooling you experience tonight connects you to temperature patterns that extend around the globe. While your part of the world releases its stored heat to the night sky, other regions are receiving the sun's energy and beginning their own daily cycle of thermal accumulation. The Earth's rotation ensures that this process of heating and cooling continues without pause, creating the temperature gradients that drive wind patterns, weather systems, and the circulation patterns that distribute energy throughout the planet's atmosphere. As you settle deeper into the night's cooling embrace, remember that you are experiencing one of the most fundamental processes in atmospheric science. The temperature changes happening around you follow the same physical laws that govern the formation of hurricanes, the movement of jet streams, and the circulation patterns that make weather possible. In the gentle cooling of this quiet evening, you are witnessing the engine that powers all of Earth's atmospheric phenomena. And even as the air around you continues its slow cooling, forces are already at work that will reverse this process. The promise of sunrise still hours away, but inevitable, carrying with it the warmth that will begin tomorrow's thermal cycle anew. In the quiet depths of this night, while you rest in the gentle embrace of cooling air and settling darkness, tomorrow is already taking shape in the invisible architecture of the atmosphere around you. The weather that will greet you when you wake, whether it brings sunshine streaming through your windows or soft rain pattering against the glass, is being written now in the patient language of pressure and temperature, humidity and wind, in processes so subtle they exist below the threshold of consciousness, yet so powerful they will determine the character of your coming day. Feel yourself resting at the center of these atmospheric preparations, surrounded by air masses that carry within them the seeds of tomorrow's sky. The pressure systems you learned about earlier, those vast, slow-breathing patterns of high and low pressure, are continuing their stately dance across the continent, even as you sleep. Hundreds of miles away, a high-pressure system might be strengthening over the Great Plains, its clockwise circulation already beginning to influence the air that will reach you by morning. Or perhaps a low-pressure center is deepening over the Gulf of Mexico, drawing moisture northward that will arrive as clouds just as you're waking to greet the day. These traveling weather systems move with the patience of geologic time, yet the precision of clockwork, following tracks across the landscape that have been worn smooth by countless predecessors. The jet stream, that river of fast-moving air 6 miles above your head, guides these systems along their paths like a celestial highway, its meandering course determined by temperature differences between the Arctic and the tropics, by the season, by the complex interactions between ocean and atmosphere that occur on scales both vast and intimate. Right now, as you lie in the darkness, meteorologists around the world are reading the atmosphere's intentions in the language of weather maps and computer models. They see in the swirling patterns of isobars and fronts the same story that is being written in the air around you. The slow approach of a warm front that will bring gentle rain by afternoon, the building of high pressure that promises clear skies and cool temperatures, the development of instability that might spawn thunderstorms in the heat of tomorrow's day. But you don't need instruments to sense these approaching changes. Your body is already reading the atmospheric script, responding to pressure changes too subtle for conscious awareness, adjusting to humidity levels that speak of distant moisture sources, feeling in the quality of the air around you the first whispers of weather systems still hundreds of miles away. The slight stiffness in old injuries, the way your hair feels against your scalp, the almost imperceptible change in how deeply you breathe. These are your personal barometers, registering atmospheric shifts with sensitivity that rivals any scientific instrument.
The temperature gradients that developed during tonight's cooling are creating the stage upon which tomorrow's weather will perform. If the night has been clear and calm, the strong temperature inversion that has formed near the ground will influence how morning fog develops, how quickly the sun can warm the air, how efficiently pollutants disperse when the day begins. If clouds have moved in during the night, their insulating effect will have kept temperatures more uniform, preventing the formation of frost, but also reducing the dramatic temperature contrasts that can trigger interesting weather. As the hours pass toward dawn, even the darkness itself becomes part of tomorrow's weather equation. The absence of the sun's heating allows certain atmospheric processes to dominate that are overwhelmed during the day. Radiative cooling continues its steady work, drawing heat from the Earth's surface and radiating it toward space. This cooling creates its own circulation patterns, gentle downdrafts and thermal settling that prepare the atmosphere for the dramatic changes that will occur when sunlight returns. The dew that may be forming on surfaces around you right now is tomorrow's weather in miniature, a preview of the larger-scale condensation processes that might create morning fog or afternoon clouds. Each droplet of dew represents the atmosphere's tendency toward equilibrium, water vapor condensing when the air can no longer hold it in invisible form. This same process, scaled up and played out in the vast theater of the sky, will determine whether tomorrow brings clear horizons or landscapes softened by mist. The wind patterns that have been so gentle tonight, or perhaps completely absent, are part of a larger atmospheric circulation that extends around the globe. While you rest in relative calm, the trade winds continue their steady flow across tropical oceans, picking up moisture that will feed weather systems days or weeks in the future. The polar jet stream races eastward at speeds that would astonish you, carrying energy and disturbances that will influence weather patterns across entire continents. Even in the stillness of your immediate environment, you are connected to these planetary-scale movements of air and energy. The moisture content of the air around you, that invisible water vapor you'd been breathing all night, carries within it the history of recent weather and the promise of weather to come. High humidity suggests that moisture sources are nearby and active, perhaps indicating the approach of a weather system from the south or east. Low humidity might signal the influence of continental air masses, promising clear skies but also greater temperature swings between day and night. The exact amount of water vapor in tonight's air will help determine how quickly temperatures rise when the sun returns, how readily clouds form during the day's heating, how comfortable or uncomfortable tomorrow's weather will feel against your skin. As you settle deeper into sleep, the atmospheric processes around you continue their work with the reliability of a fine timepiece. Pressure systems advance along their predicted tracks. Temperature patterns evolve according to the laws of thermodynamics. Moisture redistributes itself through evaporation and condensation. Wind patterns adjust to the changing thermal landscape. All of these processes follow scientific principles you could calculate, yet together they create something that feels almost magical. The daily renewal of weather, the constant reinvention of the sky. The beauty of weather lies partly in this combination of predictability and surprise. The great patterns, the movement of fronts, the circulation around pressure systems, the seasonal migration of storm tracks follow rules that scientists understand well enough to forecast days in advance. Yet within these grand patterns, smaller-scale processes create endless variation and surprise. The exact timing of a thunderstorm, the precise location where fog will form, the precise moment when rain begins, these details emerge from the complex interactions of countless atmospheric variables, making each day's weather unique even when it follows familiar patterns. Tomorrow's sunrise, still hours away, will trigger a cascade of atmospheric changes that will transform the quiet stability of night into the dynamic energy of day. The first touch of sunlight on the Earth's surface will begin the heating that drives convection. Temperature inversions will weaken and disappear as the air begins to mix. Dew will evaporate, returning its moisture to the atmosphere. The gentle thermal circulations of night will give way to the more vigorous movements of heated air, setting the stage for whatever weather drama the day will bring. But sunrise will also reveal the work that darkness has accomplished. If conditions have been right, the night may have left behind a landscape transformed by frost, every surface etched with crystalline beauty. Or morning might unveil valleys filled with fog, the low-lying air saturated with moisture and transformed into something ethereal and dreamlike. Clear skies might stretch to every horizon, washed clean by the night's radiative cooling and ready to showcase the sun's returning warmth. The promise of dawn exists not just in the certainty that the sun will rise, but in the knowledge that each new day brings its own unique atmospheric personality. The weather that greets you when you wake will be unlike any that has come before, shaped by the specific combination of pressure, temperature, humidity, and wind that developed during the night's quiet hours. Even if tomorrow feels similar to today, the precise molecular details will be different. The unique patterns of air movement will be distinct. The exact timing of thermal changes will follow its own rhythm. As you drift toward sleep, carried by the gentle mathematics of cooling air and settling pressure, remember that you are surrounded by one of nature's most reliable promises, the promise that weather will continue its ancient cycle, that the atmosphere will continue its patient work of redistributing energy and moisture, that the sky will continue to write new stories every day in the language of clouds and wind, sunshine and rain. The darkness around you is not empty, but full of potential, pregnant with tomorrow's possibilities. In the quiet movements of tonight's air, in the gentle cooling of the Earth's surface, in the invisible circulation patterns that connect your resting place to weather systems across the continent, tomorrow's weather is being born. And when you wake, you will step into a day that was created during the night by the same atmospheric processes that have been lulling you to sleep. The eternal conversation between earth and sky that makes weather possible and life beautiful. Rest now in the knowledge that the atmosphere never sleeps, that the great circulation of air and energy continues even in the quietest hours, and that the weather that will greet tomorrow's light is already taking shape in the gentle darkness that surrounds your dreams.